Okay, so in the last two projects, I have used those Nextion round displays from the new Edge series, and I thought it would be nice to have some kind of housing, some kind of enclosure for those displays. And I have a 3D printer, so I can create something like this, but can I get something made from metal? Well, the answer is of course yes, because I have a new machine called the Makera Carvera Air, and I will try to use that machine for the very first time to create something useful and, of course, as usual, show all my steps. And on top of that, I will also share a very secret tip from a friend of mine who is a professional CNC machinist. Actually, if you are only looking for the advice from the professional, you can jump to this section and see that. And I will also show you how I spent a day, actually multiple days, cutting out this piece and then ruined it in the very last step. You can see this edge, it just looks horrible, and that's completely my fault, so I had to start all over again. So with that said, let's get started. And I have two blocks of aluminium for today's project. Both of those are 10 by 15 centimeters or 100 by 150 millimeters, but one is only 5 millimeter thick and the other one is 10 millimeters thick. And that kind of dictates what kind of project I can do today, because as you can see, the bigger 2.8-inch display might fit, but it might be a very tight fit. So for that reason, I will go with the smaller display, which is only 2.1 inch, and that should give us a little bit more space around that display for some kind of enclosure. So let's get the calipers and measure the size of the display, which seems to be around 74 millimeters. And just in case, we can also check the datasheet for that display to make sure that our measurement was correct, which seems to be the case. And then we can start creating that enclosure. As with many of my other projects, I'm using the Autodesk Fusion, which you can use for free for personal projects. And I will start by creating a new sketch, so hit the Create Sketch button and click on the floor plane, which is this one. And then let's create a circle from the center of the sketch in the size of our display, which was 74.6, but let's give it some breathing space and go, for example, with 75 millimeters. So this is the size of our display. And that will be the size of the hole inside the aluminium block. And if we take a closer look at the display, on the back of the display there is this double-sided tape. So let's just create a little bit of offset on which this double-sided tape will be glued. And if I again take calipers, we have quite a lot of space in here, at least 5 or so millimeters. But that's not the case down here, so we have to account for this part of the design. And let's just measure the width of this area, which seems to be around 36 or so millimeters. So let's just keep this shape in mind and of course those numbers in mind, and let's go back into Fusion. And let's use the offset tool to offset the circle by 5 millimeters inside, so -5 to the inside. So this area will be used for gluing the display except for the bottom part. And for that one we will offset the circle one more time, but only going to -1 millimeter this time, so -1. And then we can draw the line in the size, in the width of this area. So just draw the line anywhere, just make sure that this is the horizontal line and the size should be 36 millimeters. And then we can select that line and use this constraint called the midpoint. So click the midpoint, this line, and this point, the center point, and that will move it to the center of the design. And then we can use the line to draw the line from this point down to that point on the circle and do the same thing on the left side. Finally, let's draw the outside shape of the enclosure by going to create rectangle being the center rectangle, and of course start from the center of the sketch. And just because our aluminium block is 150 by 100 millimeters, we need to go with something smaller, and I think that 80 by 80 is just way too small, so I will go with 90 by 90, so 90 by 90. That should give us a little bit of space on the outside, while still keeping enough material around the display. So click the Finish Sketch button, and then we can just rotate the view a little bit, maybe like so. And we would like to extrude those parts by selecting the Extrude tool. So for the outside of the display, which is this part, we will actually not modify the height in any way. So we will go with whatever we have, and I will use the smaller one, which is 5 millimeters tall, so 5 millimeters for the height. And then I will open the sketches and show the sketch one more time, because I want to also extrude the inner part, which will hold the display in place. So click the Extrude button again and select this part and this part. And I can rotate the view to make sure that I'm selecting the correct parts. And I will extrude it a little bit less, for example, only by 3 millimeters. Then we can hide the sketch so it's not getting in our way. And we have the base shape for holding our display. Now to give it slightly more interesting shape, I think that we can use the chamfer tool and chamfer those 4 edges, so this one and that one and this one and that one, and use whatever value feels right, so maybe like 15 or 14 millimeters. And then we can round those edges using the fillet tool, so fillet this edge and this one and also all the other ones. And for the fillet, let's for example go with 10 millimeters. Now, since I also want to try drilling, let's add some holes, and for that we will first create a new sketch, so create the sketch on the floor plane, and create a new rectangle being the center rectangle, and let's imagine that every corner will be a hole, so let's give it for example this size, like 66 by 66 millimeters, and then finish the sketch, and click the create hole button, and then click all those individual dots on this rectangle. And we only need to go to 5mm depth, and I have some drill bits with the 2.5mm size, so let's go with this size, and then click the OK button. And finally let's add some chamfering by selecting the chamfer tool and for example chamfer this edge to 1mm or maybe 0.8. And then if you want to use different values for different edges, we can click this button, so add selection set, and then select this edge, and maybe go with the same value for now. And finally, let's add one more selection set and select those holes. And for those, let's go with 1mm. Then click the OK button, and I think that this could be our final shape for holding the display. But before we actually cut it from the metal, let's try to 3D print it first. And we can either right click this body and select Save as Mesh and save it as a 3MF file, or we can just go to the file and select 3D print. Then select the body, and if you have the application already selected, like I do, then you can just click the OK button and it should start the application. And we are only loading the geometry data which is expected, and I don't want to update this Bamboo Lab Studio. And I've pretty much used all the default settings, and I've used the white PLA material mainly to make it more visible during the time lapse. So with no changes done, let's click the slice plate button to show all the individual layers, and there shouldn't be any surprises, but just in case, let's just see the model how it will be printed. And again, no surprises in here. So I think that we can click the print plate button and just print it on the 3D printer. And here is a short time lapse that was recorded by the 3D printer itself. And here is the actual 3D printed piece. So we should be able to take the Nextion display and put this inside, and of course make sure that it's aligned and rotated in the correct orientation. And it seems to fit nicely inside. Which means that it's time to recreate this 3D printed part from the metal, from the aluminium. And we will actually not use the very same 3D model, because on this model we have a lot of chamfering, so chamfering on the inside, chamfering on the outside, and also chamfering around those holes. And when we will machine those parts, we will use this chamfering bit, so this chamfering bit will go inside and outside and around those holes. And if you imagine the path, it will be actually aligned to the unchamfered edge. So I think it might be beneficial to export this 3D model without those chamferings, because then we can also control how much chamfering do we want to apply by setting how deep this chamfering bit will go into the material. So let's go back into the Fusion application. And before we export this, let's not use the chamfering by right-clicking this chamfering feature and selecting Suppress Features. So we have the model without any chamfering, and then we can export it by going to File, Export. And for the file format, let's select the step file and export it somewhere. And then we want to use that file for the Makera Carvera. And if we go to the Makera website, we actually need two different applications, the first one being the Makera Cam, that will import our 3D model and create the G-code for the machine. And then later on we will use this Makera controller to run the G-code on the machine. So let's start with the Makera Cam and download this application. And then as we run this application, we want to create a new project being the 3-axis project, so not using the rotary extension, so just 3-axis for now. And as a very first step, we want to set what kind of material we will use in our machine, so click this Edit button. And we will go with the aluminium, and our size is 100 by 50 by 100 millimeters by 5 millimeters thick. But I think that I will set the material to be 100 by 100, because when I do so, then when I import the 3D model, it will be centered in the size 100 by 100. So in theory, I can use that extra 5 centimeters or 50 millimeters of material for something else. So again, I will go with 100 by 100 by 5 millimeters and click the OK button. And then we can import our 3D model by going to File, Import 3D Model, and select that exported step file. And then just like in any other 3D tool, we can just rotate the view and see the 3D model. Although it acts slightly different than, for example, in Fusion, but yeah, we can see the model. Now the good news is that unlike the 3D printing, we don't have to do everything at the same time, so we can just start from bits and pieces and just gradually remove the material from the aluminium stock. And I think that I would like to start with this inner part with this lip that will hold the display in place. And if we open the options for 3D path, we have a few of them. We can, for example, try to use the pocket tool, so to remove everything like inside, so select the 3D pocket tool. And then we have to click the face, so this face, I want to remove this face or everything that leads to this face. And for the tool itself, I will click the add tool, and I will go with the metal bits and use the biggest one, this being 3.1 whatever by 12 millimeters. And all the settings should be automatically set for us based on the selected material, so just click the choose button, and then we can try to go all the way to the bottom and click the calculate button, and that will calculate the path, but it's actually removing much more than we need to. The thing is, we only need to remove material from this face, from this area, because later on, in the next step, we will remove everything from the inside, like so. So by removing all the material from this area, it's just a wasting of time. And we can actually preview what's going on by selecting this preview toolpaths, selecting the toolpath and clicking the preview button, and then click the play button, and we can slightly speed it up like so. And as you can see, we are removing everything from this area which is unnecessary. So let's just exit the preview and delete this path by simply right clicking and selecting delete. And yes, I want to delete that one. And instead of using the pocket toolpath, let's go with the simple contour toolpath. So select the 3D contour, and then we need to get the path from the 3D object by selecting the face and clicking on that face. Then click the generate contours and then select the path which is the outer one. I will use the very same tool, so choose tool, and I will use the biggest one for metal, again this one, and click the choose button. I think I will keep all the default settings. I want to cut inside, and just click the calculate button, and you see that we have now this kind of toolpath. Again, we can preview this toolpath, so select this toolpath and click the preview button. And I don't know how much visible it is, but it's just cutting inside like it's expected. And let me speed it up a little bit for you, but this time it's actually not cutting enough material. And that's because if I show the model, and you can imagine how big the bit is, so it's about that size. We are only cutting this material away, but we still need to cut this part away. So we probably need a second path, so let me just duplicate this 3D contour, so duplicate that one, and then edit this toolpath. And just because this tool has the step over set to 2 millimeters, so that's the distance between individual passes, I will offset this path 2 millimeters inside and click the calculate button, and it seems like that we need to again select that very same face. So select that face, generate contours, click the outer one, and then click the calculate button. And we have a second toolpath which is offset by 2 millimeters. And I think that this should be sufficient because again, this is, it will remove this kind of material. And this is the second toolpath which should hopefully go over this edge. But just to make sure and be on the safe side, I've created the third one by duplicating that one and offsetting this not by 2 but by 4 millimeters. And I think that we need to still select that face, so click the clear contours, select that face, generate contours, select the outer one and click the calculate button. And we should have 3 toolpaths in here. It looks something like this, and we can again click the preview toolpaths button and preview all those toolpaths. Click the preview, show it from the side, and then run it and maybe speed it up a little bit. So it will cut the first one, the second one, and then the third one. And by the end of this operation, we should have something that looks like this. Now before we export this as a G-code and send it to the machine, I will make one small change, and that is to edit the toolpath. And down here there is something called the ramping. And what this does is it gradually moves the tool into the material. So right here, if I can find the beginning of the toolpath, it will just go straight into the material. But if we enable ramping and maybe set some distance, like, I don't know, 20 millimeters, and click the calculate button, you can see that now it gradually goes into the material, and we can probably extend the lifespan of that bit a little bit. So click the calculate button and close it, and do it for the second toolpath, so edit and enable the ramping with the same parameters, and click the calculate button. And then for the third one, edit and enable the ramping, 20 millimeters, calculate and close. And I think that we can actually cut this from the aluminium now. And to do that, we need to first export those three toolpaths as the G-code, and you might notice that they say T4, that's for the tool, and the tool number is quite important on the Makera Carvera machine, which has the automatic tool changer, which is not my case because on the Air version there is no automatic tool changer, but we can still edit this path and maybe change the tool number to be the tool number 1. And do that, of course, for all three paths. So now all the tool paths are T1, so the tool number 1. And then we can export those as a G-code by going into the path menu and selecting export. And we can still change the tool number in here if we decide to do so. Just make sure that all those three paths are selected, and then click the export button. And of course use some meaningful name. And save that file somewhere. And before importing that G-code into the other application, let's actually take a closer look at the Makera Carvera machine. We need to put a block of aluminium somewhere on this work area, and while we can put it anywhere, it kind of makes sense to put it on the left bottom corner, because if we do so, this point, this bottom left corner of the aluminium block is actually the 0 point. Now to keep the block of aluminium from moving anywhere, we need to somehow secure it, and we can use screws on this bottom, and then we can use those clamps to also secure the other edges. Now one important thing to keep in mind is the size of our part, which is 90 by 90 millimeters. And just because the stock size is 150 by 100 millimeters, that means that on the shorter side we have 5 millimeters above and 5 millimeters below. But we have to account for the bit size, and we will be using this bit, which will go on the outside, and the diameter is 3.175 millimeters, which means that we have only about 2 or so millimeters for those clamps. So we don't have much space, but let's try that and hope that nothing bad will happen. So with the aluminium part secured in place, we will actually not yet insert the tool into the machine, but instead we will go back to the PC. And in here we want to download and run the other tool called the Makera controller. And you can also get this tool for your phone, either the Android or iOS, but for now I will use the Windows version. And what we want to do first is to connect to the machine, and we can either use the USB connection or the Wi-Fi connection. Actually, the first time you connect to the machine, you need to use the USB connection. And here's a pro tip: usually when you buy USB cables, they are kind of short, even the one provided with the machine isn't very long. But you can buy longer cables. I was able to find one which is all the way to 8 meters long, that's pretty long. Although I haven't tested this one, but I have tested the 5 meter version and it was working without any problems. That said, I've already set up the Wi-Fi connection to my machine, so I should be just able to click this menu button and connect to the Carvera Air machine. And I think that I am now connected, which means that I can upload our G file clicking this button. And here we can see what's being currently stored on the machine itself, so we have some examples down here, but I will go into the root folder. And instead I want to upload our G-code, so I'll click the upload file button. And let's locate that G file, which is this one, and then click upload and select. And that will do exactly that, so it will upload that file into the machine and select it, and we can see the preview of our toolpaths on the right side. So we can run this on the machine by clicking this button. And here is some configuration which was slightly confusing because we do see the L bracket, which is on the left bottom. That's where we placed the aluminium block, But we actually don't see the aluminium block itself because that will be like maybe, that size or this size. So this will be the aluminium block that we have inside the machine. And then this green line is the toolpath, but it's actually not the toolpath itself, but only the boundaries of those toolpaths, which might look something like this. So we have 3 toolpaths offset by some amount, and please excuse my very crude drawing skills, but this will be actually cut from the material itself. So even when it looks like that it's not starting from the 0, 0 position, it actually is starting from 0, 0 position. It's also shown in here. It's just that our toolpaths are not going from 0, 0, they are slightly offset. And we can better see it in the Makera Cam application. So this is the 0, 0 position, but you can see that the toolpath boundaries, they are starting from around here. Inside the settings, there is this scan margin checkbox, and if you check that checkbox, it will use the laser pointer to show the area where it will be cut. So it will show the boundaries of all those toolpaths. And then we have this auto Z probe, and that's this red dot, and that's the place where it will measure the thickness of the material. But if you are not sure if the thickness of the material is the same across the entire surface, you can also use the auto leveling feature, and that will basically measure all those individual points, all those individual thicknesses, and it will account for any height variations. Now, while this feature is more aimed for things like PCBs or some thinner materials, and our aluminium block should be pretty flat, I don't think it will hurt to use that feature just so we can see how it works. We can now press the run button because as long as we have the auto Z probe or auto leveling enabled, the machine will actually not do anything, not do any cutting before it does those operations. And in order to do those operations, we need to use the probe tool, and the machine will fortunately wait before we insert that probe. So again, we can press the run button and nothing will happen, except that it will play the beep sound and tell us to insert that probe tool. And with the quick tool changer, we can just put down the lever and then insert the wired probe tool, which is stored on the right side, and then put up the lever to secure it in place. And the machine light should be blinking in blue color, waiting for us to press the one and only button on the machine. And once we do, the machine will measure the height of the probe tool, and then it will show the toolpath area using the laser pointer on that probe tool. That's the green rectangle which we have seen in the Carvera controller application. So let's wait until it finishes showing the boundaries. And then it will move the probe down to measure the height, the thickness of the material. And just because we've selected the auto leveling feature, it will actually do the very same operation 25 more times. So let me speed it up a little bit. And once this will be done, the machine will play the beep sound, and the light strip on the machine will blink, but only the first section. That indicates that we should insert the first tool. So let me actually do that. Let me take out the probe tool and instead insert our bit. And once this is done, we can again press the one and only button on the machine. You can see that on the back, on the right side, it's again trying to measure the size, the height of our tool. And then it will move the tool over the aluminium block and finally start cutting. Now it might not be visible on this video, but I've closed the lid of the machine because once we start cutting, those chips will fly everywhere. Also because I'm using the air compressor, which is advised to use when you are cutting metal. I've actually used the air assist from my laser machine and it's working just fine. And the air is coming from this small pipe and blows the air on the tool and on those chips. Also at any point, we can see what's being currently machined inside this Carvera controller application. And you can also get this tool for your phone, but only one application can be connected to the machine at a time. So if you are connected from the PC, you cannot connect from the phone and vice versa, unfortunately. So let me speed things up a little bit and maybe jump forward in time slightly. And this is currently cutting the second toolpath. And here is a close-up view, and I think that you can nicely see that after this small machining there are just quite so many chips inside the machine. So when you are operating this machine, you will use a vacuum cleaner a lot. Okay, so now this is finished, but I will not remove the aluminum from the machine just yet, because I want to chamfer this outer, this bigger edge. And for that I will use this chamfer tool, which has the 90-degree tip. And that will travel on this edge on this path to create a nice chamfering, and we can set how much we want to chamfer this by setting the height or the depth of this tool. The nice thing is that as long as we keep the aluminum inside the machine and don't remove it, we don't have to do any probing because it will remember all those values. Which means that we can immediately insert this chamfer tool into the machine and go back to PC. And in the Makera Cam application, let's hide those 3 toolpaths which we have already machined. And let's create a new toolpath, and that will be the 3D chamfer toolpath, so create a new 3D chamfer. And we want to chamfer this edge, but I think that we need to first click this edge and then select Generate Contours, and then click the edge itself. So this will be the chamfered edge. And of course, for the tool itself, we will use the one and only chamfering tool, which is, I believe, inside the chamfering bits. And that's this one, the 90-degree chamfering tool, so choose that one. And it's setting the chamfer depth to 1 mm, which I think that is nice start. We can start with 1 mm and see how it looks like. So let's just keep all the default settings, except maybe for the tool number, I will choose a different tool number from those 3 toolpaths, so maybe tool number 2. Because I think that if I keep the same tool number and don't do any probing, the machine will think that the tool is already in there and it will just not, wait for anything, and it will just start cutting right away, which is not something that I want. So I will just set it to a different tool number even when there is no tool changer on the Carvera Air machine, and then click the calculate button and it will calculate this tool path, which looks like this. It should go on the edge itself and just cut inside. And let me see if we can simulate this path by clicking this preview toolpath and then simulate all 4 paths and run the simulation, and of course speed it up a little bit. So the first one, the second one, the third one, and then there will be this chamfering going on. And since this looks like how it should look like, let's export this toolpath by going into Path Export and only export the last one. And so this one will be the chamfering, and save it as a G-code. And then jump into the Carvera controller application and open that file. So click the upload file and select that file and select upload and select. And this will be much shorter and much quicker compared to the previous toolpaths. So click this button to run the G-code. And I don't think that we need to scan the margin, and I don't think that we need to run the Z-probe again, because again, since we have the machine still running and we haven't moved the aluminum block anywhere, all those settings should be still stored inside the machine, so we can go right to cutting and just click the run button. And after the machine measures the height of the tool, it will start cutting, and again, this is a fairly quick operation. I think it takes about 2 minutes or so, but of course this is a speed up version, just so I'm not wasting any of your time. And in the end, we should have a nice chamfered edge. So let's continue with the next step, and it will be remove everything inside, so we have a space for the display itself. And that will be of course machining out this area, but we don't have to machine everything inside, we just need to machine this path, so we will just remove this inner section. And I think that for this we can again use the 3D contour toolpath, so click the 3D contour. And then we will select this face, so this top face, and generate contours and select this contour. And then for the tool itself, we will again select the biggest metal tool that we have, which is this one, 3.175mm flat mill. And there is a small problem which might not be immediately visible, because we are cutting inside of this. You can imagine that there is this tool just traveling around this path. And let me actually show this in Fusion. So this is our 3D model, and we want to cut the inside, and this is the size of the cutting tool, so you can imagine it's just traveling around this path, and this is probably fine. We can just cut this corner without any problem. But for this inner corner, you can see that no matter how close we get to this corner, we can never cut this area from our part. And I think that the easiest way how to fix this is to actually modify this model to not have those sharp edges, but to round them a little bit. And we need to round them by at least half the size of our tool, so 1.5 something millimeters. So I think that if we go with 2 millimeters, we should be fine. So let me just rotate the view and select the fillet tool and fillet this edge and that edge. And I think that we can as well round those 2 edges, just so we don't have any sharp corners. And since we need to go with at least 1.5 millimeters, let's go with 2 millimeters, and that should be safe. So now if we move our tool along this path, we should be able to cut this corner without any problem. So let me just quickly re-export this model one more time, again without the chamfering, and save it as the step file. And let's just not use this path for now, and let's import the new 3D model, again by going to File, Import 3D Model, which is this one. And then we can create the 3D contour path, again click this face, and then click Generate Contours, and select the inner one which is now around it. And go with our biggest metal tool, which is this one. And now if we hit the Calculate button, it will show us the path, but it will only go to this point. If I show it from front, you can see that it only goes to that face, but we want to go all the way to the bottom. So what we need to do is to adjust the depth offset, which is currently set to 0 millimeters. And since we are going down to 2 millimeters and our stack size is 5 millimeters, we need to continue another 3 millimeters. And if I click the Calculate button, now it goes all the way to the bottom. But now we have a different problem, because once we cut this, it will just fall apart and it will most likely do something wrong. So we don't want to do that. So what's suggested is to use tabs, and tabs are small areas which will not be cut, so it will be still connected between the outer part and the inner part, and then we need to use some kind of saw or tool to remove those parts. And now it's finally the time to tell you the super secret trick from my friend who is a professional CNC machinist, and he told me don't use tabs, that's just too much work, and instead don't go all the way to the bottom of your stack, so maybe keep a little bit of material still in there, so maybe go only to 2.9 instead of 3 millimeters. So there will be a little bit of material, so like 0.1 millimeter around this area, around this whole section, so again it will not go all the way to the bottom, it will just end slightly above. And then it should be possible to cut using the knife tool. So let's try that, let's calculate, again I will change the tool number to tool number 1, calculate and close. And let's try to replay all those tool paths. So click the preview and run it and speed it up a little bit. And we should hopefully end up with something like this, where we can easily remove the inner part. So let's export this tool path, only that one, save it, and then jump to the Carvera control application. And of course load that file, so upload file, which is this one, upload and select. And I think that you already know the next steps, and that is clicking this button. We don't need to scan the margin, and we don't need to use the Z probe, so just click the run button. And I think it's time for another time lapse, because it will take some time to machine this area. So let's speed up the playback a little bit. And you might notice that even with the air assist, with the air compressor, some of those chips are still being trapped inside. And that's quite unfortunate, because those chips might result in a slightly worse looking edges. The good news is that this inner part will be covered by the display and not visible. So let's finally unscrew those screws and remove the part from the machine. And you might be wondering, how do we know where to cut this part from the back of the stack? And it's actually quite obvious once you flip it, and if it's not visible you can either press it slightly to reveal the shape, those edges a little bit more. So let's take the knife and cut this inner part, and 0.1 mm of aluminium should be very easy to cut. I did clean up the edges a little bit afterwards using the very same knife, but in the best case we would use another chamfering pass on this edge to make it clean. But again, this is inside and will be covered by the display. And we can finally put the display inside to see if it fits, which seems to be the case. Obviously we need to position it correctly to be in the right angle, but the hole size for the display seems to be perfect. So let's move on with drilling those 4 holes. And while we can use the very same cutting bit that we were using previously for all those contours, I wanted to try to use a dedicated drill bit. So I've ordered those drill bits from Makera, and there is a slight problem. I mean, this is how they look like, and this is how they should look like when I want to put this inside the machine. So there should be this black piece which is called the collar, I don't know how to say it. In any case, we need to put this black thing on this drill bit. And as you might expect, it's a pretty tight fit, so you need some kind of tool to do that, but thankfully with the Carvera Air machine you will get a lot of tools. One of them being this strange looking one, and you want to unscrew everything, and then put this black part inside, then insert those 2 spacers, and then put in the actual drilling bit, and then we need to screw those two parts together and then keep turning this handle until it will not be possible to turn it anymore. And you see that during this process the bit actually goes outside, so just be aware of it and don't cut yourself. And then when it's not possible to turn this anymore, we need to unscrew everything again. And here is our drill bit with the black thing on the correct position. So we have the tool ready and we can create our tool paths in the Makera Cam application. So let's hide this contour toolpath and create a new toolpath, which will be the 3D drilling toolpath. And for that we want to select our holes, which is kind of hard to do because I keep selecting the thing that I don't want to select. So let's just select only the holes, and as the last step I will deselect the outer one by shift clicking the face. And then for the tool I of course want to use the drill bit, and I have the 2.5mm drill bit, which is this one. Again, it will be already predefined with all the correct settings, but if we take a look at the shape of our drill bit, if we only go all the way to the bottom of our stock, we will actually not cut all the way through, so we need to add some extra space, some extra depth to make sure that it goes all the way through our material into the waste board, which is being placed below our stock. So let's select this tool, and for the depth offset let's just use another 0.5mm and then click the calculate button to calculate this path. And if you look from the front, you can see that this tool path goes slightly below the stock, so it will go into the waste board. Now for drilling there is some additional settings called the retract, which will basically just drill slightly into the material, then go outside, then drill, then go outside. And I think we want to do that to easily remove those chips. And finally change the tool number to some different tool number, for example tool number 3. Click the calculate button again, and then of course export this tool path, so path export. And only export the drilling path as the G-code. Then load that G-code into the Carvera controller application, so that one, upload and select. And we do see 4 drilling holes, so just send this to the machine, and since we have removed the aluminium block from the machine and now we've put it back, just in case let's also run the Z probe, so enable the Z probe and then click the run button. And as expected, the drill bit will start drilling those 4 holes, and as we've said, it will actually go down below the material into the spoil board. That's the yellow brownish board below the aluminium, and it's there so you don't accidentally cut into the main metal base. Obviously you can buy a new spoil board from Makera, but if you have a laser cutter you can get plans for this board on printables and just cut your own from MDF. So let me speed up the playback of the drilling process of the remaining 3 holes. And I think it's nice to always add a little bit of chamfering to not have those sharp edges. So let's jump back into the Makera Cam application. And here we will add a new 3D chamfering toolpath around those 4 holes, using the one and only chamfering tool. Then generate this toolpath, export it as a G-code, import the G-code in the Carvera control application and send it to the machine. And just because those holes are very small, this process should be very quick, but in any case let me speed it up a little bit. And this is how those chamfered holes look like. Now at this point there is only one thing left to do, and that is to cut the outside shape. And you should already know how to do that. We will use the 3D contour toolpath. And let's switch the view and select the bottom face and click the generate contours and select the outer contour. And then for the tool we will again use the biggest metal tool that we have, which is this one. And same as for the inner part, we will not cut all the way through, but we will leave some space in between. For example 0.1mm, so we'll set the end offset to be minus 0.1mm to not go all the way to the bottom. For the tool number, let's go with the number 1, and let's enable the ramping, and click the calculate button. Now you can see that it doesn't look quite right. We are cutting inside our shape, but we want to cut outside, which means that we need to change the position from inside to outside, and then click the calculate button one more time, and I think that this path looks correct. So let's do the usual steps, select the toolpath and export the toolpath as the G-code. And load the G-code into the Carvera control application, so upload our new file. and then send it to the machine. And this process will take some time. Actually, it will take a lot of time because we have the step down set to 0.2 millimeters. So at any time it will only go 0.2 millimeter deep into the material, which means that for our 5 millimeter stack it will need to go around this shape 25 times. As a result, it will also produce a lot of chips, and even when I have the air assist still on, so the air is still blowing on the tool, a lot of those chips still stay inside this cutting area. And again, that's not what we want because it will make those edges, those cuts slightly less perfect. So during the cutting process, I've actually opened the lid of the machine and vacuumed some of those chips away. And it was kind of surprising to see that opening the lid of the machine didn't stop the machine, which is usually the case, I mean at least the case for the laser cutters. Also, if you take a closer look, you can see how close we are with the cutting tool to all those clamps and screws, but thankfully it didn't collide with anything. So after this cutting was done, I've decided to do one last step, and that is to add the chamfering on the outside edge. Which means adding the 3D chamfering toolpath on the outside edge, then selecting the correct chamfering tool, going on the inside, and then exporting this as the G-code and importing that into the control application. However, after sending this to the machine, it just went sideways. I think I've set the wrong position for the toolpath. It should have been outside, but it was inside instead. And as a result, you can see that the bottom of the cut of the chamfering is not clean, it's just somehow like very fuzzy. But I was hoping that as it will go down into the material, it will correct itself and it will clean things up, but that didn't happen. As it was progressing, it was only looking worse, and of course looking back, I should have stopped that machine at that point. But I didn't, and that was a mistake. And it was a mistake because I'm chamfering it down to 1 millimeter, and as I've later find out, it's not possible to set any bigger value than 1 millimeter for the chamfering. So I cannot just easily set the correct position and bigger chamfering, but I need to go all the way to square one and start again. So that's definitely a lesson learned. The good news is that once you do something for the second time, it's always faster. The bad news is that wasting material, wasting aluminium, of course, costs a lot more compared to, for example, 3D printing. With that said, I think this is still great. I would never think that I would be able to produce aluminium or metal parts in my home using some desktop CNC machine, but here I am having the Carvera Air machine and I'm having a great time with that. Compared to 3D printing, there is much steeper learning curve, but I think that the result is just worth the effort. I will definitely use that machine for my future projects, and I have a lot of ideas, but right now the biggest bottleneck is of course my knowledge. So that's all for today. Thank you very much for watching, and I hope to see you soon. Thanks and bye.